All right, I will now be showing proof 5 on our first quiz proof list, which says that if some sequence x sub n converges to x and it also converges to some other thing y, then it must be the case that x is equal to y. And so this is a pretty easy proof, which for anyone who's done real analysis before, you've probably seen it a couple of times. But basically, we just exploit the definition of convergence that says that for any epsilon over 2 greater than 0, there exists some n sub 1, which is a natural number, such that for any n greater than n sub 1, xn minus x must be less than epsilon over 2. We apply the same definition of convergence, this time to xn and y. Now we'll note that, for some epsilon over 2, there might be some different natural number, n sub 2, such that for all n greater than n sub 2, x sub n minus y is going to be less than epsilon over 2. So what we do is we choose our n to be equal to the max of either of these, n1 or n sub 2. And then for all n that are greater than big N, we'll use the following triangle inequality. So x minus y is equal to x minus x sub n plus x sub n minus y. Then we apply the triangle inequality here. And then, as we've shown up here, each one of these terms must be less than epsilon over 2, which is equal to epsilon. And so for any epsilon greater than 0, we have shown that x minus y, that this holds rather. So this holds for any epsilon greater than 0. And so it must be the case that x minus y, the absolute or the norm, the distance, is equal to 0, and that x is equal to y in that case. And so now we have shown the uniqueness of a limit for a convergent sequence.